I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of ACE, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. In this session, we are going to discuss about one of the core component which is used in the embedded system design, that is 8051 microcontroller. So, if you look at the first one by one, we will go first embedded system architecture. Generally, embedded system is defined as embedded the firmware into hardware to do specific one or few highly focused jobs, often with real-time constraints. So here, the requirement is defined in the form of instructions. That is called firmware. This firmware will be executed by the core components. These core components may be either microprocessor, microcontroller, digital signal processor, application specific integrated circuit, field programmable catering system. We can use any one or few of these core components for executing the instructions. Next, these instructions will be stored in the memory devices. And while doing the operations, we are getting the current data from the input devices like sensors. And the device is controlled, like airbag is opened, wheel is locked, like that. That will be controlled by using actuator, by sending some control signals from the system. And do the special functions by using special hardware, ADC, DAC, real-time clock, watchdog timers, and share this information among all these peripherals by using communication interfaces, either RS-232 cable, USB cable, or I2C cable, whatever may be. You can use any one. So, among these, we are going to discuss about microcontroller. So, microcontroller means it is a single silicon chip that also represents central processing unit, and it contains on-chip memory, on-chip I/O ports, on-chip additional hardware, and communication peripherals. Suppose, if you look at the microprocessor, that is a CPU. Central Processing Unit. It contains arithmetic and logical unit, control unit, working registers. This is example for microprocessor like 8086. When comparing with microcontroller, this microcontroller contains CPU, means all like this. CPU, memory, input devices, output devices, additional hardware, and communication buses within the chip. So, what is the advantage of this microprocessor? If you are designing the applications using microprocessor, at that time it requires external memory, external input and output devices, external hardware circuits like analog to digital converter, digital to analog converter, and external communication peripherals like RS-232 cable, USB cable, or I2C, SPA, UART, whatever. It will require external peripherals. So what is the disadvantage when comparing with 8086? Sorry, 8086, the limitation is we require external peripherals for designing particular embedded system. So whatever the cost of this external peripherals, that cost will be included in the overall cost. So cost of the embedded system increases. At the same time, since these peripherals are externally connected or interfacing with the CPU, it needs to access the information from external peripherals. Means accessing time increases. Accessing time increases means execution time increases. Execution time increases means speed reduces. So, in this point of view, microcontrollers are somewhat more speed than microprocessors. That is one parameter. Second, since we need to purchase external peripherals for a particular system, the cost of the embedded system increases. So, speed reduces, cost increases. Next, since whatever space occupied by these external peripherals, overall system size will be increases. Size increases. Since we are using external peripherals, whatever the power consumption increases. Power consumption increases. And power dissipation also increases. Automatically, since more heat is generating, it requires cooling fans. Need cooling fans. So all these are the limitations of microprocessors when comparing with microcontrollers. So most of the time we can prefer microcontrollers for designing the embedded systems like 8051. We can check some features of 8051 microcontroller. First, 8051 is a 8-bit microcontroller. Here 8-bit indicating how many bits of the information will be accessed in the single clock cycle. So since it accessing only 8-bit means its data bus width is 8 bits. That means it can access the information from 0 to 255 value. Okay, at a time. Next, it contains oscillator circuit which can interfacing with the 12 MHz clock. Next, it contains 16-bit address bus. Means it can generate 2 power 16 addresses. That means the address range is 2 power 16 means 2 power 6 into 2 power 10. 2 power 10 means 1 kilobyte. 2 power 6 means 64. So totally it can interface up to 64 kilobytes of memory locations, either on chip or off chip. So it can generate the 2 power 16 addresses, means 64,000 something, and means 64 kilobytes memory locations. Okay, next. So it contains RAM, the primary memory within the chip. Within the chip, it contains the RAM. That capacity is 128 bytes. Okay, and its capacity of the ROM is 4 kilobytes. So address of the RAM that ranges from, we can use this any of these memory locations. Okay. Next, it contains 128 bytes special function registers. Okay. 4 kilobyte memory space assigned for secondary memory. 128 bytes memory space is assigned for primary memory, that is RAM, random access memory, read-only memory, and 128 bytes memory location is assigned for the special function registers. All these are within the chip. Next, it contains 32 general purpose input and output lines. These 32 input and output lines are divided into 4 8-bit ports. Port means some group of pins. So each port contains 8 pins or 8 lines here. Totally 4 ports. Those ports are port 0 to port 3. Port 0 to port 3. So these can be read the data from the peripherals and write the data into the peripherals. It will perform read operation and write operations from the peripherals. It contains 2 16-bit timers. Those are timer 0 and timer 1. Okay. The timer width is 16-bit. So means 2 power 16. This 8051 do the Boolean operations also. Means bit addressable operations. Bit operations. And on particular bit, it will do the operation. Either logical and logical or operations. That feature also available in the 8051 microcontroller. And 8051 contains 6 interrupts. Interrupt means disturbance. Or while doing the operations, some external peripherals may require the CPU for doing its operation. Highest priority tasks or whatever the tasks. Suppose I am executing some code. I am doing some simulation. At that time, I may play the music. Or while reading some document in the mobile phone, may I get the incoming call? May I get the incoming messages? May I get the incoming video calls? So, based on the priority, so incoming call is highest priority when comparing with reading. So, that service needs to be served. Means the user get the incoming call. Even whatever the operations done by the user in the mobile phone. Either playing the music, playing the games, or reading the documents, whatever may be. Okay. Again, if power is off means that mobile is switched off. That is also another priority. Stop the or terminate the all currently executing tasks. If we press the reset button, whatever the operations we are doing in the mobile phone, all tasks are terminated. So reset is the highest priority. Or shutdown is also one of the highest priority. Okay. So coming to 8051 microcontroller, it contains two timer interrupts. Those are timer 0 interrupt and a timer 1 interrupt. And it contains two serial interrupts. Serial means bit by bit. At a time, only one bit will be transmitting. Serial communication. So here, transmitting interrupt is there, receiving interrupt also. And it contains two external interrupts. Those are EX0 and 1. And it contains timing unit for doing the timing related operations, for synchronizing with other tasks. And it contains control unit for doing the control operations. It contains on-chip universal asynchronous receiver and transmitter for sharing the information from this 8051 to the external peripherals. Okay. And it contains 111 instructions in 64 single cycle instructions. This 8051 IC physically available in dual inline packages and PLCC packages. So these are the features of the 8051 microcontroller. Next we will check the 8051 microcontroller architecture. So this is the architecture of 8051 microcontroller. So if you look at this architecture, first it contains oscillator circuit for giving the timing reference to the tasks, and it contains arithmetic and logical unit for doing the arithmetic and logical operations, and it contains timing and control unit for doing the timing reference to the tasks, at the same time control the peripherals. For this timing and control unit, it contains program strobe enable pin, that is active low pin, address latch enable to access the address of the information or instruction. Suppose if the on-chip memory is not sufficient, at that time we need to enable the external access pin. That is also active low pin. Whenever you are connecting that pin to the ground, then only it will be activated. Here active low means. Next it contains reset pin for resetting the system if any hangout occurs, system is hanged or not working in the designed manner. At that time we can press the reset button. These are the processing units. Next, it contains 128 bytes on chip RAM, 4 kilobytes E2 PRAM or EPRAM here. And for special function registers, it contains 128 byte size. It also contains RAM address register here. It is accumulator, ACC means. All these are processing and memory devices. Next, it contains 32 general purpose input and output lines. So here totally the 32 lines are divided into 4 ports. Port 0, port 1, port 2, port 3. Okay. These 32 IO lines are divided into 4 IO ports. Each port contains 8, 1, 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7. That is port 0.0 to 0.7. Port 1.0 to 1.7. In the same manner. port 2.0 to 2.7, port 3.0 to 3.7. So totally it contains 4 8-bit IO ports. Okay, each port contains 8-bit information in the single and corresponding latches. Coming to the additional hardware, it contains program counter for fetch the next address of the next executed instruction. It contains timer controller, timer mode register, serial controller, process controller, timer 2 controller, timer 0 low, high, low and high, timer 2 low and high, timer 1 high and low. It contains instruction pointer, interrupt and serial ports, timer blocks. It contains stack pointer, okay, data pointer, buffer, program address registers, okay, program status words. These are some additional circuits. And it also contains UART. Okay, so like this 8051 microcontroller contains CPU, on-chip CPU, on-chip memory, on-chip IO ports, and on-chip additional hardware and communication peripherals for doing the arithmetic and logical operations, control operations. Since it contains within the chip all these peripherals, it accesses information from within the chip itself. So no need to purchase external peripherals. So its cost is less when comparing with microprocessor based design. Its execution time is less when comparing with microprocessor based design. Its speed is more when comparing with microprocessor based design. Its power consumption is less when comparing with processor based design. Its power dissipation also less at the same time. No need of cooling fans, size reduces. So all these are benefits by using microcontroller based embedded system design. So for this topic, we can refer the textbook is Introduction to Embedded System by Shubhu KV, manufacturer is Tata McGraw-Hill, second edition, that is published in the 2019. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.